Welcome to another installment of the C Suite Spotlight. I couldn't be more thrilled to be joined by Shashi today, where we're going to be able to talk about what's been happening largely in stealth mode for the last couple of years at DeGirum. So he has actually welcomed me to his turf here in Santa Clara at their headquarters. We have something in common, and it's not that the computer engineering skills. We both went to the illustrious University of Arizona.
Yeah, nice to meet a fellow Wildcat.
Bear down. Before we go too far into DeGirum, one of the things that I'm always fascinated about is to learn what got you into engineering to begin with.
I wish there was some inspiring story I can tell you here, but the truth is, growing up in India, there were like two viable career paths then. So you're good at math, you become an engineer. You're good at biology, you become a doctor.
Okay.
But kidding aside, like my father is an engineer. So he's a civil engineer and he worked for the government in the roads and buildings department. So kind of grew up in a very, in a household that was very centered on education, engineering, and very math focused. So it was kind of natural for me to take that path.
A story that is inspiring and interesting. Tell us a little bit about, so after going to the U of A and getting your PhD, you joined Marvell. You stayed there for a few years and somehow DeGirum was born. Tell us about that.
Yeah, so actually Marvell was my first job out of college. And in fact, it was the only interview I ever did in my life. So in all respects, I think Marvell is like a phenomenal company because what I did at Marvell was kind of seemed like a continuation of my PhD. My PhD is in coding theory, so we were working on LDPC codes, trying to understand why they have something called like an error floor. At that time, Marvell was looking into transitioning the solid storage devices, SSDs, from what are traditionally known as BCH codes to LDPC codes. So I joined that group. It was whatever I was doing for my PhD was directly applicable there. So it was a very thrilling environment to work because, as you know, Marvell is very engineering focused. There is like some excitement working on what we call like a first generation product, right? Where there is like a tremendous gain. So after a few years, AI was just coming up. We started hearing more about AI, and at that point, I decided maybe kind of do a career pivot and learn something new. I quit Marvell and looked around for a few months what to do next. So I was learning different types of software. I wanted to do something in the education market, trying to see how ML can be applied there, and so on. Started learning computer vision, how these algorithms work, and so on. Mm-hmm. I got to meet Pantas, who was the CTO and co-founder of Marvell, and we got to talking about the opportunities this space afforded, and that's how DeGirum came to be.
If you can talk a little bit about the co-founding partner and how that maturation happened.
Yeah, sure. So by the time I actually talked to Pantas, he was already working with Winston, and they were looking at an IP that was basically related to moving data around on a fabric. So it was a very technical IP related business, and the way they were moving data around the nodes was in kind of like a circle, and that's where the name DeGirum comes from. So it's Latin for a roundabout. So the original technology was actually centered around that idea. So Winston and Pantas were already working on those ideas, but when I joined, we started discussing because IP is like a very tough space to be in. So, and we decided that the team kind of was ideally suited to build something in AI because one thing, there were no standards. So which means that if you have a good product, you are not really constrained by any standard, or good product can win in this market. So at that point we decided that we'll start focusing on building an AI chip for inference.
And fast forward a couple years, how has that vision matured?
Yeah, so we started with basically the idea of building an AI chip. Even at that time, even in late 2017, it already seemed like a very crowded market, because everybody was kind of trying to build a new chip. Everybody was looking for some kind of advantage, right? Either in architecture or in terms of system design. We started working on supporting sparse networks or pruned models, because some of it is related to my background in LDPC codes, which are also based on sparse matrices. So I had some ideas on how we can leverage sparsity to improve the model performance in terms of speed and the memory footprint. From there, we started kind of building the architecture around this idea, and we were successfully able to tape out our chip and came back and started working pretty well.
And if somebody were to ask you or to characterize DeGirum as a chip company, would that be accurate?
I would say that when we started out, that would have been accurate. But now I think we have outgrown this description of being a pure hardware company. Right now, when we actually talk to prospective customers or strategic partners, we always present ourselves as a complete AI solutions company, because we have outgrown just the hardware and working more towards on the software as well as our cloud platform.
I think some of the most exciting areas are on the software side of DeGirum's solution. Can you speak more about how you differentiate?
On the software side, I think one of our biggest strength is that our software is agnostic to the hardware. That means whatever software stack we develop not only works for our hardware, but it works with other hardware as well. We kind of see this as a key differentiator, because this allows people to actually not get logged into one hardware, but also use the same software stack to evaluate other hardware as well. When we got our chip back and started talking to prospective customers, everybody basically had the same question. Why should I spend any time on evaluating your chip? Every hardware company says that they have the best chip. Every hardware company says that they pair it with software that makes it very easy to use their hardware. If you think about how long it takes to evaluate a hardware, so let's say this hardware is available commercially, that you can go to some website and buy, right? First of all, there are not many that are in this stage yet, right? But even assuming that you are at this stage, you go order this part, it comes, you find like a box into which this product can fit, you install its software, you find the models that can run, install all the software tool chain, and get the application to work. Anywhere between 2 weeks to a month, right? In fact, when we talk to people, they say, oh, we have this chip sitting on our desk for last month, right? Nobody having the time or the resource to evaluate it. So we were asking, how can we get this time down from a month to under 5 minutes? So that was our original intention. We had this idea that cloud computing is well known. Everybody is providing resources in the cloud. Why can't we let people evaluate our chip in the cloud? So we started working on this infrastructure where we actually put things in the cloud and through simple software give people access to this hardware so that they can start evaluating this. This paid off big time, I would say, because now we don't have to give them a data sheet. We don't have to tell them how many tops we have, what is our frames per second. People can just sign up for our cloud platform and run this in under 5 minutes.
It's really unheard of to give away your software. Why would you do that?
Yeah, I think there are a bunch of reasons. First thing is that, of course, this is good for the customer, right? So people want a unified software stack so that whatever efforts they put into bringing up one hardware, it does not go waste when trying to port it to other hardware. The whole idea has been customer driven, that one of our customers suggested that can you make it as easy for other hardware as well? Because we were at a test chip phase, they already wanted to get early into the market, so they were saying that if there is other hardware, can I use your software, because it was like so easy to use. The second reason is that we are actually an accelerator chip. So that means we are not a standalone SoC where people can just work with our thing. So it is always paired with another SoC. So it can be an x86 CPU from Intel or AMD, or it can be any ARM-based single board computer, like a Raspberry Pi or Banana Pi, any of this, right? So since it is always paired with a host, which itself has some capability to run AI compute, right? So we wanted now to give a unified stack so that people don't have to learn two softwares. So this gives them one unified thing. Even without your accelerator, I can get started on the base SoC. And if I want to expand, then the same software can be used to seamlessly offload some of the AI loads to our hardware. So we see this as actually providing a huge advantage to us, because once people are used to our software, when there are choices of multiple hardware, they would choose our hardware because it already works with their software stack.
And so being able to really treat the entire ecosystem, or to be able to offer a solution that covers the entire ecosystem, because I assume that you would license your software?
Yes.
Okay. If somebody chooses a different hardware accelerator, can you talk about the ease of transition back if they end up deciding that they do want to go with the DeGirum chip?
Yeah, so basically the way the whole software stack works is that there is a notion of loading a model. And what we have done is the model name contains two important parameters. One is called a runtime, the other is called the device. So basically, let's say you have a state-of-the-art model like YOLO V8. Right? You can run it on multiple devices like CPU, NVIDIA GPUs, or on our Orca, or on Google's Edge TPU. Right? So what we have done is that model name encapsulates not only the model architecture, but it also tells that this model has been compiled, let's say OpenVINO CPU, or it will say TensorRT GPU, or it will say N2X, which is DeGirum's runtime. It will say N2X Orca, that's the name of our chip, or it will say TF Lite Edge TPU. Once you change this model name, and if the device that you are working on is equipped with this hardware, it will automatically run.
Wow.
So that means that actually application developers will write code that is completely agnostic to hardware, but also to the model. They will just write it as some variable name in a configuration file. And if they switch the name, if the hardware is available, it will run on the available hardware.
Incredible. Can you talk to us about what one of the biggest or most exciting market responses has been to this?
The biggest response, I would say, is people now feel that out of the box, they can actually get AI applications to run, because the software is so easy to use that we actually have only 4 lines of code for any model. There is the notion of connecting to a model zoo. A model zoo is just a collection of models. So that's line number 1. Line number 2, you pick one model and you load the model. You can say, face detection model is equal to zoo.load model and the model name. And then there is a third line where you basically give source of the input. It can be an image, it can be a video stream, it can be a YouTube URL, it can be an RTSP stream, and you basically say result is equal to model of this source. And then the fourth line is just visualize the output. You say result.show, and then you will see the output. And these 4 lines of code works for any model. It can be a classification model, it can be a detection model, it can be a segmentation model. It works both in the cloud and locally. So that is, it is agnostic to where the hardware is located. It is agnostic to what model you are running, and it is agnostic to what the underlying hardware is. We actually feel that it cannot get simpler than this.
Yeah, and this brings us to one of the most exciting elements, and one of the reasons why I believe strongly in DeGirum's success is that this will help advance the democratization of AI. That's something that in our conversations in the past has seemed important to you. Can you talk to me about why and how this might help that?
Because today, even though a lot of resources are available, AI is not truly democratized in a sense that there is still a big barrier for people to actually get started. Right? So, like one might argue that, hey, there are so many PyTorch repositories, right? You can clone them and start running models. Right? But what we see is that people are writing the same code over and over again. So since there is no unified abstraction that basically lets them, let's say, we have like object detection where you have to draw bounding boxes. So you have a webcam and you want to run an object detection model on this. Pretty much everybody is writing this code over and over again. They open a camera stream, they get a frame, they decode this frame, they resize this frame, they send it to the ML model, they get it out, they write some Python code to visualize this box on the frame and to show it on the screen, right? Imagine doing this for different hardwares. Imagine doing this for different types of models. So what we are trying to do is get rid of all of this boilerplate code. Of course, we cannot cover all the cases, we know this, but we believe that 70 to 80% of the cases are well understood and you should have like simple code to do this. And I think this will basically enable a lot of people to get into edge AI. Now with the help of our hardware and software and cloud platform, we believe that 2 company startups are possible to basically make an AI product. I think nobody doubts that edge AI is going to be huge, right? But it is not concentrated in few places. There are thousands of applications, each one with maybe thousands to 10,000s of volume. Imagine a company who has an opportunity to deploy a 1,000 device kind of solution. Let's say they see like a $3 to $4 million opportunity, right? They cannot build a they cannot build an ML team. They cannot invest so much on all of this bring up, right? But if this is available, like if with the help of our cloud platform and software, such a development and deployment is indeed possible. And actually we think that this is the type of democratization that we can make possible.
Switching gears and coming up an abstraction layer from the technology that you've been building to building a company. You spent 8 years at Marvell and then went and started your own startup. That's quite a journey. What are some of the challenges that you faced in building DeGirum over the last 7-8 years?
I think one thing that I saw the biggest change was that when we were in Marvell and going and talking to customers, we were kind of the experts, right? So there was a lot of credibility because Marvell is such a big company. We were at the forefront of developing things. Things get reversed when you are a startup, right? So I go and I talk to people, and they are like, why should we trust you, right? Why should we actually believe that you can make a chip? Why not just go with the market leader, right? So like establishing trust, I think this was one of the big challenges, especially in hardware space, where even to get to demo real hardware, it can take anywhere from 2 to 4 years to actually show the first silicon. So I think this was one big challenge. The second big challenge is to actually get the right set of people, right? Especially to build a hardware and a software company. It cannot be done with 2 or 3 people. I mean, we have heard a lot of software companies making a lot of strides with a very small core team. But in hardware, I think this is just not possible, right? So assembling the right team, I think this was the next big challenge. The third challenge, even after having a good product and good software, is to actually convince people about the usefulness and getting people to understand all the advantages and increasing the adoption. Right? So even though Edge AI has been well known for the past few years, deployments have been, I think I would say most of them are still in the proof of concept stage. Right? That means hitting large volume is going to take some time. So this means that it requires a lot of patience. So that means we should be able to, willing to endure this kind of uncertainty for a large extended period of time.
You have assembled quite a team. How have you and Winston been able to get not just the right technical skill sets, but also the right culture? Can you talk to us a little bit about the culture that you've built and how the team that you've assembled have been responsible for buying into that culture?
Yeah, I think most of the company founders would actually say that team is their biggest strength, right? But I think in our case we actually believe it 100%. Culture is not something that we put on the website as a mission statement, but something that evolves with the company, right? We are still very small, so that means actually we are not very showy, as we are not as popular as maybe some other companies in the space. And if you see, our team is also like that. So we have attracted people who actually try to work under the radar, very focused on what they do. And actually, I want to take this opportunity to really talk about our team. We actually have once in a while we have all hands meeting, and we always begin the meeting with actually talking about people. What this small group of people has been able to accomplish. At least to me, it is a miracle. We have a design team which is just 3 people, believe it or not. A team that has brought a chip to production is 3 of our engineers, Bhaskar, KP, and Bob. Phenomenal design talent. All of them have decades of experience taping out a chip every year. But they have made this possible, which I think, I don't know if anybody is maintaining statistics, but I would think 3 people pulling off a design must be some sort of record. We have a software team that is led by Konstantin. He was actually one of our very early hires. So I remember, actually Konstantin was, I worked with him in Marvell, and I was very new to Marvell at that point, and I had to do some code refactoring, and I had no idea. So I was working on over the Christmas break, and Konstantin saw me, and he just came and helped me over the entire Christmas break. Right? So when we wanted somebody to lead software, I asked him. We met him for we met for a lunch in Red Robin, and he heard patiently heard for an hour or so whatever I had to say. Next day he messaged me, I'm in, right? So from that point onwards, he built the software team, phenomenal engineers. They never ask us, why is the valuation of other companies so high? They never ask us these kind of questions, because they know what we are building or what we are trying to build is going to take time, and for people to realize its value. We have our ML team lead, Merdad, fellow UFA alumni. He and I actually had the same PhD advisor, though we didn't have any overlap. So he joined us, and now he does 3 things. He leads the ML team, develops all the models. He writes compiler for our hardware, which is one of the most difficult things that anybody can do, because it actually requires very strong software skills, but it actually needs a lot of hardware skills also, because he has to know what works for the hardware. As if these 2 are not enough, he actually does RTL verification, because he's the one who actually knows the design. He writes the part of whether the hardware is designed correctly or not. So that means a person like this is worth, 10 good engineers, I would say. Right? I mean, you must have heard this, right? There are some engineers who are worth 10 engineers. So we have a bunch of those engineers here. We have our firmware lead, his name is Igor, single-handedly brought up the design, chip on day 1. I don't know whether there are any statistics or not, but our chip last production version came back on April last year. It was a Friday. I was very, very nervous, right? Because for us it was kind of a make or break moment, right? Then at 2 o'clock, Igor calls and says, "Yeah, CPU is up, PCI is up. I'm running ResNet, performance is as expected, right? So this is like, a few stories from each of like very strong engineers, and the way we found these people is that we kind of talk to them and explain what we are trying to do here, and most of them, because they knew us from before, they kind of just joined us on the journey.
Wow, what a story. As you're continuing to grow, Bob was able to share some exciting things on the horizon. As your second and third generation products start getting worked on, and you think about scaling the company, what are the things that you look for in engineers that do things the DeGirum way?
I think we are generally look for people with very strong fundamentals. Even though we are like an AI or ML kind of company, we actually believe that learning AI or ML on top of what you know is much easier than somebody like who already says they know ML but learn other things like strong software programming or building products. We try to identify this type of traits during kind of talking to people, like what motivates them if they immediately start asking, what was your last round, what is the equity. I mean, we know this is very important to everybody. We are not trying to minimize the financial aspect of things, but if people are asking more about technology, more about how do we differentiate, we know that they are the right type of people to work with. We look for a strong background in programming like C++ or like a strong math background. Once you have good linear algebra type of background, picking up ML is not very difficult in our opinion.
Let's assume success. What impact will DeGirum and the DeGirum solution make on the world?
We are always optimistic about success. So I keep telling my team that we have to be very paranoid, but also infinitely optimistic about success. That's the only way to succeed in a startup. If all of our ideas pan out, I think what we hope will happen is that lot of edge AI applications will come to market much faster. So that means people should be able to take off the shelf hardware, take whatever accelerators are available, quickly assemble prototypes, get good models, and develop proof of concept, and then go to production from there. And if we can enable a few hundred companies like this, people who have like small opportunities, not everything can be $1 billion opportunity, right? But tens of millions of dollar opportunities we feel are there to be exploited in this space. And if we can enable a few hundred of these companies, I think that is when we would consider ourselves successful.
Is there somebody or a group of people that you would consider to be foundational mentors of yours that have led you to this point?
As I mentioned, working at Marvell played a huge role in shaping my career. I had a manager there, his name is Greg, really encouraged me from the beginning, from day one actually. Kind of taught me how to think about hardware optimization and so on. Like, coming from academia, it was a slight shift of how to think about taking things to product. Right? My PhD advisor, Professor Bane Vasic, he has been a huge influence on me. He's a very well-known figure in the storage industry, and always encouraged me, always gave me like the right opportunities, gave me the freedom to explore. And of course, Pantas at Marvell has been a huge influence because he has been guiding us for the past few years, not only as an advisor, but also as an investor. And we can call him anytime. Always kind with his time and advice.
What would be one piece of advice that he's given you that you think has had the most profound impact?
Yeah, I think one thing he told us early on was that focus on the core technology, right? Don't let marketing gimmicks get to you, right? So if your core technology is good, just try to showcase this. People will eventually see it. Of course, it also goes without saying that every good product needs marketing. But he said before you get to that point, first make sure that you have the good product. Right? Don't put marketing before engineering.
As we wrap up here, if people want to get a hold of you, want to learn more about DeGirum, what would be the best avenues for them to do that?
Our website is a very good starting point where they can actually see the uh, links to all our cloud platform, what we offer, and so on. We are quite active on LinkedIn, so generally people get in touch with me on LinkedIn, either looking for an internship or looking for a job, and I try to respond to everybody. Typically, people can reach out, they can try our platform. I think if somebody says that I tried your platform and I have a question, I think this is the best way to. You will definitely get an answer from us.
Okay. Well, that sounds good. In the time that we have remaining, would you have time to show a demo?
Absolutely. I want to start with our cloud platform. What we like to demo is that people can get started with the cloud platform without actually having to install any software and run inferences right in the browser. So when you log into our cloud platform, you will see that you have access to the model zoos. And we have a public model zoo that shows a lot of models running across different devices. So for example, I can pick a detection model that runs on Orca. And for example, I can pick the MobileNet V2 SSD, a quite popular model. And I can choose any input. So here I choose a picture of two lovely cats, and I can run inference right in the browser. So it will run the inference, it will show the results, and it actually also tells you the inference duration. So that means when you have the hardware locally, you can expect that from this model you should be getting about 110 frames per second. So the cloud platform gives you this inference in the browser that already gives people a lot of models to play with of different types. So they can do classification models, they can look at detection models, post detection, detection of YOLO, and so on. We also have models that are called listed model zoos, so tailored to different application use cases. So for example, we have trained a bunch of models for car detection on the COCO data set, face detection, hand detection, human head, and a bunch of these models. So they can go to any of these model zoos and they can do the same. So here you have car detection models running on Edge TPU, CPU, and Orca 1. So you can choose Orca 1. You have YOLO V5NU, SU, 8N, 8S, a bunch of different architectures. So you can choose any of them and again run an image, and you can see the performance. So once you get a feel for the software inside the cloud platform, what you can do is actually we maintain a GitHub repository of our models. So our PySDK examples repository contains a lot of examples on how to use our software. On any of the example, if you click, it will open up as a Google Colab notebook. So that means you can actually run code. So it will allow you to change things and experiment. You can change the model, you can change some parameters. So this is basically still no software installation needed from your side because the installation is handled in Google Colab, and then you can just run the code. So the same MobileNet V2 SSD model the same 2 cats image. Now I'm actually running the Python code to get the result. What we hope is that people would see this and say, okay, it is now worth our time and effort to actually install this software on our local machine. So that means this basic PySDK demo image example that I'm showing, they would feel that, okay, we can do the same thing and install it locally on our machine. Right? And once they do that, they can actually run the same code that I have shown you. Right? So, and this runs the same way locally also. So this is actually running in the cloud, right? So that means even though the software is installed locally, it is using hardware that is located in the cloud.
Okay.
And once people get hands on our hardware, all they need to change is they change this cloud to local and run the code again. Of course, as you can see, it is much faster because it is running locally. So this is basically what we call location agnostic software. That means the software doesn't really depend on whether your hardware is located locally or it is located in the cloud. So this will allow people to develop applications in the cloud and deploy them at the edge when they are ready to make the commitment to buy the hardware. Second feature that I'm going to highlight now is that we move on from a simple demo of running on an image to something little bit more exciting of running on a camera. So here we can start with a Intel NUC that is actually equipped with our Orca, but I'm going to start a demo which actually runs the face detection model on the CPU itself. So no accelerator needed. So it is just running the YOLO V8N model on the CPU. So this is a human face detection model. And as you can see that even on the CPU itself, it is able to run 30 frames per second. Wow. So which means that people can start actually developing applications right on the CPU, right, without actually waiting for any accelerator. So this will enable people to start AI application development with whatever hardware they have. One of the features I was telling you about our software was that it was hardware agnostic. So that means that this same code, we should be able to run it on Orca with minimal changes. And here, as you can see in the model name, we have encoded what is the runtime and what is the device. So that means this model is running on OpenVINO on a CPU. So if we change this to N2X, which is our runtime, and Orca 1, the same code will run now. So which means that developers actually can write code without worrying about what is the underlying hardware. Right? So from this part of the code, from here onwards, there is no real mention of the model or the hardware. Once you decide where is the hardware located, what is the name of the model, the rest of the code remains the same. And of course, it not only works with CPU and Orca, but we also have a Google Edge TPU, Corel, connected here. So I can change N2X to TF Lite and Orca 1 to Edge TPU. And you will get again the same models running. So typically this is the amount of code needed to run inference on a camera. But the beauty of our software is that it allows you to actually run multiple models. That means, you know, the amount of code that is needed to run 3 different models on a camera is actually only this much. So intuitively, if you think about it, you have to specify what the name of the models are. So here I specify that there is a hand detection model, a face detection model, and a person detection model. And you specify the video source. Video source 0 means the webcam that is attached to my system. And you connect to the model zoos, you load the models and basically say predict stream on this video source, combine these three models into one model. Right? So that means run them in parallel, and when you do that, you actually see that you will get an output in which you are running three different models at the same time.
Wow. Incredible.
But the code is so easy to write that you can actually have two different cameras and run one model on each of them. So you basically say that define my two models, hand detection model, face detection model. Say that hand detection model, run it on video source 0, face detection model, run it on video source 1, show me the results. And now you have basically two different models running on two different cameras.
Wow.
So actually this is one of the main strengths of Orca, is its ability to multiplex models.
Yeah.
So most other AI hardware accelerators can do very well running a single model at high performance. But when you have to run multiple models, when you have to switch models, they suffer a lot of performance degradation.
Absolutely.
Because we have DRAM on our side, this allows us to basically store models on our side and then quickly switch models whenever needed. So that's kind of our hardware strength as well.
Incredible stuff. You guys are doing something I've never seen done before.
Thank you.